Hey mathletes, in this video what we're going to look at is we're going to look at solving quadratics in one of our algebraic approaches. This time what we're going to do is we're going to solve by factoring. The one thing I want you to keep in mind for all of these questions is we could solve all of these graphically. It's never a bad idea to do that first and then solve algebraically, but I'll leave that up to you to do. Let's look at the first one. Let's solve this thing. So to solve, what we're going to do is we're going to factor. And in this case, because one side's equal to 0, what we're really finding is we're finding those x-intercepts. So I'm going to factor this thing. So our two numbers that multiply to negative 15 and add to 2 are 5 and negative 3. And then what we have from here, so what is x from here? Well, what we have now are two mini equations. Either 0 is equal to this or 0 is equal to that, because you had two numbers, x plus 5 and x minus 3, that multiply to give you 0. So then, what is this? This is x is equal to negative 5, x is equal to 3. And if you would like, you could write that in a solution set, just like that. Okay, let's look at B. Again, what we're going to do is we're going to factor. So this one is not a trinomial. This one has a greatest common factor. So I'm going to factor out a 2x, and I've got a 3x minus 2 left. And again, now what I do is I make two little mini equations, just like that. And we isolate for x, and there's your solutions. And again, if you wanted to write it that way, there's your solution set. Okay, so we've done a simple trinomial. We've done something just with the greatest common factor. C is a difference of squares. So remember, difference of squares, you take the square root of the first term and the last term, and the sign in between switches because they're conjugates. And again, what we do now is we solve. So either the first is equal to 0 or the second is equal to 0, and we just isolate for x. And there we go. We get positive, negative 3/2. That's it, friends. This is how we're going to solve by factoring. It's not that difficult. Now, what we're using is actually something called the zero product property, where if something's equal to 0, we can solve really, really easily. So one way to solve a quadratic equation is to factor and then use the zero product principle or property, where you set one side equal to 0, then we know the two factors must equal 0. So what I'm trying to tell you, if you're doing this thing by factoring, you better make sure one side of your equation is always equal to 0. That's it, my friends. Let's do one more. Solve algebraically this trinomial. So this trinomial is a complex trinomial. It's not called complex because it's complex to do. It's called complex because it gives potentially complex roots, but it is definitely more work than a simple trinomial or any of the other three we just did. So remember, what you do is you say you got to look at these two numbers. You say what two numbers multiply to negative 24 and add to negative 5. Right? So what two numbers do that? Well, those two numbers sound like 8 and 3 to me. And now there's many ways to factor a complex trinomial. I'm going to do it in two ways. Okay, I'll first use decomposition, and then I'm going to use a much quicker way called inspection. And really, it depends just on how your teacher showed you this in 10C. So remember, decomposition, all I'm going to do is I'm going to decompose minus 5 into the two numbers that we just found over here, negative 8 and 3. Then what we do is parenthesis, 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 parenthesis. We take out our greatest common factor from each set of parentheses. So in that one, I'm going to take out a 2x. In the second set, I'm going to take out a 3. I know I've done this right because I see x minus 4 is a factor of both of my terms. So now I'm going to factor x minus 4 out of the whole equation. And what do I have left? 2x plus 3 is equal to 0. And now that we've factored, now we can solve. So the zero product property, set these both equal to 0. Right? Some people, me included, like to say therefore. And so therefore x is equal to 4, x is equal to negative 3/2. And again, if you wanted to write that as a solution set, it would just simply be that. So factoring a complex trinomial is definitely going to be an important skill that you have to know how to do. Okay, this is a must know how to do. For 20-1 and 30-1, you have to know how to factor a complex trinomial. So I did that one using decomposition, but that's not how I usually factor these things. I factor them using another method called inspection. So watch how I'm going to factor this time. So I'm just going to rewrite our trinomial down. So I still have to play the game of what are the two numbers. So I still know those are my numbers. And then I'm going to do this. Skip all this decomposing stuff. Okay, what do I know? Well, I know I've got to have an x and an x. And they've got to multiply to 2. So it's got to be 2 and 1. That's the only thing that's going to multiply to 2 that's an integer. And now here's what I do. Switch to pretty pink. I just do this. I look at my two numbers. So I go 3 divided by 2. No, I can't do it. 3 is not divisible by 2. So I go 3 divided by 1. Well, that's 3, and it goes in the other bracket. And then I say to myself, let's go to pretty orange, negative 8 divided by 2. Negative 8 divided by 2 is negative 4, and bam, there it is. If you notice, I get the exact same thing as we had right there. So that's called inspection. It's a heck of a lot quicker, my friends. But again, I really don't care how you do the question. If you decompose, you inspect. Again, I know a couple more ways to factor these. I don't care what you do. The only thing I care about, let's get the right answer. All right, amigos, there is how you solve by factoring.